Albert Einstein. Albert Einstein, 1879 to 1955, was a German-born physicist and mathematician who is widely considered one of the most influential scientists of the 20th century. He is best known for his theory of relativity, which fundamentally changed our understanding of space, time, and gravity. Einstein's contributions to physics were many and varied. In addition to his work on relativity, he also made important contributions to the study of Brownian motion, the photoelectric effect, and the development of the atomic bomb. Einstein was also an outspoken advocate for peace and social justice, and he was an active supporter of civil rights and disarmament. He was a lifelong pacifist and a vocal critic of war and militarism. Einstein was awarded the Nobel Prize in Physics in 1921 for his work on theoretical physics, specifically for his discovery of the law of the photoelectric effect. He was also a prominent public figure, and his fame helped make him a symbol of scientific genius and humanistic values. Albert Einstein was one of the most brilliant and influential scientists of the 20th century. His contributions to physics, mathematics, and philosophy transformed our understanding of the universe and laid the foundation for many of the technological innovations that we enjoy today. Here are some of his most notable achievements. 1. The theory of relativity. 2. EMC superscript 2-3. Brownian motion. 4. Photoelectric effect. 5. Unified field theory. The theory of relativity. The theory of relativity is a scientific theory developed by Albert Einstein in the early 20th century that fundamentally altered our understanding of space, time, and gravity. There are two main branches of the theory: special relativity and general relativity. Special relativity is concerned with the laws of physics in inertial, non-accelerating frames of reference. The theory proposes that the laws of physics are the same for all observers, regardless of their relative motion, and that the speed of light is always constant. This means that the perception of time and space can differ between different observers, depending on their relative motion. General relativity is a more comprehensive theory that describes the behavior of gravity and its effect on the curvature of space and time. The theory proposes that matter and energy curve the fabric of space-time, and that this curvature determines the path of objects moving in the presence of gravity. This explains phenomena such as the bending of light around massive objects and the motion of planets and stars. One of the most famous consequences of the theory of relativity is the equation EMC superscript 2, which expresses the relationship between mass and energy. It states that a small amount of mass can be converted into a large amount of energy, as demonstrated by the atomic bomb. Overall, the theory of relativity has had a profound impact on our understanding of the universe, and its concepts have been confirmed by numerous experiments and observations. It is considered one of the cornerstones of modern physics and has led to many technological innovations, including the development of GPS and the study of black holes. EMC superscript 2. The equation EMC superscript 2 is one of the most famous and important equations in physics. It was first proposed by Albert Einstein in 1905 as part of his theory of special relativity. In this equation, E represents energy, M represents mass, and C represents the speed of light in a vacuum. The equation shows that energy and mass are interchangeable, and that a small amount of mass can be converted into a very large amount of energy. The equation has been verified through numerous experiments and is used in a variety of applications, from nuclear power plants to medical imaging. It has also had a profound impact on our understanding of the universe and the nature of matter and energy. Brownian motion. Brownian motion is the random and erratic movement of small particles suspended in a fluid or gas. It was first observed by the botanist Robert Brown in 1827, who noticed the irregular motion of pollen grains in water. The motion arises due to collisions between the suspended particles and the molecules of the fluid or gas. These collisions cause the particles to move in a zigzag pattern, with their direction and speed changing constantly. The motion is named after Robert Brown. Brownian motion has many practical applications, including in the study of diffusion, the measurement of viscosity, and the development of stochastic processes in mathematics. It also played a crucial role in the development of the kinetic theory of gases, which helped to explain many macroscopic phenomena in terms of the behavior of individual particles. Photoelectric effect. The photoelectric effect is a phenomenon where electrons are emitted from a material when it is exposed to electromagnetic radiation, such as light. It was first discovered by Heinrich Hertz in 1887, and its explanation later became a key development in the development of quantum mechanics. The photoelectric effect occurs when a photon, which is a particle of light, strikes an atom in the material. If the photon has enough energy, it can knock an electron out of the atom and create a free electron. This process is used in photovoltaic cells to convert sunlight into electrical energy. The photoelectric effect is important because it helped to confirm the idea that light behaves as both a wave and a particle. It also provided a way to measure the energy of photons, and led to the development of the concept of the work function, which is the minimum amount of energy required to remove an electron from a material. The photoelectric effect was explained by Albert Einstein in 1905, using the concept of the photon and the idea that energy is quantized. This work contributed to the development of quantum mechanics, which is the branch of physics that deals with the behavior of particles on a very small scale. Unified field theory. A unified field theory is a theoretical framework in physics that seeks to explain all fundamental forces of nature in a single mathematical framework. In other words, it aims to unify the fundamental forces of nature, namely gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, into a single consistent theory. The idea of a unified field theory has been pursued by many physicists, including Albert Einstein, who spent much of his later years attempting to develop such a theory. Einstein believed that unifying the forces of nature would provide a complete understanding of the universe, and he spent much of his life searching for a unified theory. However, despite many attempts over the years, a complete and consistent unified field theory has not yet been achieved. The development of such a theory is considered to be one of the greatest challenges in theoretical physics. Various theoretical frameworks have been proposed to unify the forces of nature, including string theory and loop quantum gravity. These theories suggest that the fundamental forces of nature arise from a single underlying structure or principle. However, these theories are still largely untested and remain the subject of ongoing research and debate in the physics community. Social and political activism. Einstein was a vocal advocate for peace, civil rights, and disarmament. He was a prominent figure in the anti-war movement and a supporter of Zionism. Einstein's work continues to have a profound impact on our understanding of the universe, and his legacy as a scientific and social icon remains strong to this day.